Okay, so I am back. Just a second, guys. Okay, so I am back. Let me check whether I am online or not. Uh, so youtube.com forward slash this question mark search query. I want to search for. Let me change my room. These people are speaking. Um, uh, just a second, guys. Okay, let me check whether I am live or not. HTTP from scratch part 2.5. Let's see whether I'm online or not. I really need to get the hang of this OBS stuff. Yeah, I'm live. I'm live. That's good. Uh, let's just start the video now. Wow, what's this? Let's just leave it. Where were we? Where were we? Yes, I was checking. Yeah, we were checking some error stuff, and we concluded that there isn't any C equivalent of this Go error io.eof. So let's just continue. So we need a while loop, and I think instead of looking, we should look for this stuff in the docs as well, so that we know where's what in the documentation. So we shouldn't just follow along with this stuff. I it's How am I reading the stuff? uh, Main.go. Okay, so we are reading from a file script, a file object, and that file object is available through the OS module, if I remember correctly. So I'm gonna go in the docs in the OS documentation and go find read under the file object or something. I don't know the names of these Go primitives. We need to go into IO. We don't need to go into IO standard library. We need to go into OS. OS. Where are you? Operating systems. When we need to go and index. No. I don't know what the hell is this stuff. Type process, type file mode. Okay, type file info. No, type file. Under the type file. Okay, so it's type, it's not object, it's a type. Okay, so a variable of type file is weird. Open. No, we need to read from that file. We're reading and we're putting it into a slice. Okay, check. Okay, and any error encountered at the end of the file, read returns 0 dot. Okay, so we found it in the docs. I don't. What's this IO stuff? Is IO available by default in Go? We're wasting time again, but I want to waste my time. Yes, yapping. Package IO. So I think if you import OS, IO gets imported by default. I don't know. Be new. OS, and I want to read. I made this guy, and then I while true. I what? How do we put while loops in Go? So we don't have a while loop. We have a for loop. So I think this looks fine. This looks fine. Just put for and then okay. Okay. For uh, data equal no. We want count error. We want to declare these both and initialize them both equals to file dot read data, and then we fmd dot print line uh, red bytes. We can just copy this guy. uh, 6k p 2k end of line v uh, this guy and this. Okay, so okay, we read a number of we read bytes, then we printed them, and then we checked if count equals 0 and error equals io.uf break. And is this a bad way? Else else if this is just a bad way of writing, let's just keep quiet. Else if um I'm just guessing here, I think this is how the syntax works. Else if error not equals to nil, I think it was nil. uh, fmt dot, can we log, let's just do this guy, log dot fatal, whatever this is, dot fatal error, and let's try to let's see how log dot fatal works. Let's just change the frame of the file and clear go run main dot go. Let's just do that. Undefined IO. So then you import OS, you don't import IO. Go, and so you're gonna have to import IO, and you have, I think there was a good way. So let's just also read this. For without a condition will loop repeatedly until you break out of the loop or return from the enclosing function. So it's an infinite loop. But else we need to check if else. So we have, do we have else if? Yes, we have else if. We don't have brackets, and we just have this guy. Okay, so we wrote that guy correctly. What's this guy? You have a declaration and initialization statement, and then you have a condition. So this is also an interesting syntax. A statement can precede conditionals. Any variables declared in this statement are available in the current and all subsequent branches. Okay, so you made a num, and then for all of these conditions, if this guy fails, even in this condition num exists. So num exists. Okay, okay, in the body of else as well. Okay, and this is weird. I don't, okay, they must have thought of something when allowing this. Logical operators like and or, okay, and or are available, and equal is also available, and mod is also available, and I think that's enough. There is no ternary if in Go, so you need to use a full if statement even for basic conditions. That is not good. Maybe there's a reason. Maybe there's a reason. We don't know. I think we have seen this code is all right. Let's just also check standard library and go to log. We haven't go installed anything, so done like go install something. So log is also probably in the standard library somewhere. And we also got to know like you if you import OS IO is not available, so you have to import that separately. Is there something else? No. Okay. What was I looking for? Log, yeah. So package log implements a simple logging package. It defines a type logger with methods for formatting output. It also has a predefined standard logger accessible through helper functions like print, fatal, and panic, which are easier to use than creating a logger manually. So you create a type, an object of this type, and then you call different methods upon it. So maybe like if you make a logger and then you define the format of its logging, like how will it log errors, how will it log uh, a simple output or something, how will it log this, how will it log that, and then uh, through the constructor or something, and then you can log that stuff, or you can just use these like three methods of this package, and okay, we call them helper functions, okay, and that way you don't need to create a logger. That logger writes to standard error and prints the date and type of each logged message. So you can get date and time, which is useful in some cases. Every log message is output on a separate line. So, oh, output is a verb. Okay, okay, I got confused for a second there. If the message being printed does not end in a new line, the logger will add one. Oh, that's smart. The fatal mess functions call os dot. Okay, so fatal functions call os dot exit after writing the log message. Exit one. Okay, exit with status code one. It's like return one in C. And the panic functions call panic after. I don't remember what's panic. I don't know what panic is. Man, panic. It. This is a good opportunity to see. Man, my escape panic. Okay, there's nothing appropriate for panic. So there isn't anything like panic in C. Let's just see what panic is. Panic is equivalent to print followed by call to panic. What is panic in C? A panic.c. These guys made something. In the Linux kernel, there is something known as panic.c. I am not. I don't have the intellect required to probably read this shit. I don't know what's happening here. So give me English, man. This is weird. There's like processor directives, but these names are domain specific. I'm having a hard time making sense of this. I just need English. In C, there is no built-in panic function like in some other programming languages. Instead, developers typically implement a custom panic function to handle critical messages by printing an error message by a standard error and terminating the program immediately using the exit function. So panic is just like printing and like exiting with a error message. It's not something like super amazing or I don't know. It's a high level primitive, high level concept. Call to panic. Ah, come on, man. Let's just leave it. Let's just leave it alone. We don't need to know everything. Um, fatal. We were looking at fatal. Fatal is print caller by call to a OS protected one. Thank God, something sensible. Yeah, so it saves us a line or two. It makes our code cleaner, so we can just like what the hell is this? So we also have a weird :q file. rm :q rmt rm main clear ls. Yeah, that looks better. And then we have, if error not equal nil, log.fatal error yank set relative number. We need to go to, okay, we already have a 9j. We already have a log.fatal thing here. I think everything seems to be all right. And what's this guy? Like, I think we have everything working. Yeah, we have everything working. Yeah, there doesn't seem to be any issue. Uh, why is okay. Okay, so that's what the logger is supposed to do. It's supposed to print the date and time, and then it's supposed to print the error, and then it's supposed to exit with status code 1. Uh, and uh, okay, so we're reading 8 bytes, and in the end, we're reading 3 bytes. And when the file ends, we return. That's that's good. That's good. We are taking a lot of time in this stuff. So os.open, read 8 bytes from the file into slice of bytes, print the 8 bytes in this. Oh, man, I hate. Red. Okay, so they have a queue. Let's just leave it alone for now. So they, I want to see what is this. We need to know where things are, right, in the library. We have fmt dot. Uh, yeah, we have these flags. And what does %q mean? A single quoted character later safely escaped with go syntax. I don't know. Let's just leave it. Printing. It's analogous to printer for scanner, but it's easier. Do they have a %s somewhere? They do have one. An uninterpreted bytes of the string or slice. I'm gonna use %s. It seems more familiar. I don't know what percent %q means. Let's see whether everything works. Go run main.go. Everything is working, but there is an issue. It isn't interpreting backslash n. It isn't writing backslash n. It's Yeah, it's considering it a new line character. So if you want to literally print what characters are in your buffer, so then you should use %q. So safely escaped. So it escapes the escape characters and it prints them literally. So if you have a backslash, it prints that backslash as a backslash. It doesn't treat it as the beginning of an escaping character. Okay, okay. So calling you now makes sense to me. How should we write this? Let me get my charger real quick. Where do I'll have to put my laptop here. Uh, Maybe this is gonna work. Yeah. I'm, um, I want to put my charger like this. Yeah, I'm just changing my setup because of my charger. Um, okay, let me change my location. I'm gonna have to change my location. Uh, I really need to get a dedicated room and stuff and a setup for my stream. Uh, hmm, I'm gonna have to change my location again. I'm just gonna go back to where I started. Just a second. I'm almost done. I'll be back soon. Uh, yeah, let's continue. So now we have to, we've completed this part and now we've done all this stuff. Now, what was I doing? Yeah, I was saying I want For now, um, print the 8 bytes as text. So from this message, it seems like they want me to literally say what backslash n is. So I think I should do this like %q. Go run main dot go. So basically, what's happening here is that everything in the string in the buffer is within the inverted commas, and after that you go to a new line. It makes more sense that way. Percentage s wasn't making that much sense. It wasn't looking good. Like if you have this prefix, one expects the output to be on one line, and if you have a backslash n at the end. Let's just move on. I think we have wasted enough time here. New lines reading 8 bytes at a time is a good. What's happening? What the hell is happening? Reading 8 bytes at a time is a good start, but 8-byte chunks aren't how people tend to communicate. You probably noticed that it was hard to read the individual messages through the program. Trust me, this all leads to HTTP. I promise. We do hope that. Assignment, let's update the code to continue to read 8 bytes at a time, but now let's format the output line by line. So it should now print the data in the same format. Okay, it should print it like this, but now we have a full line in the output. But now percentage as, so what I'm not going to read this. I'm not going to read here's what I did. I'm just going to do it. It's just so simple. I don't need to follow. Uh, I'm gonna create a buffer. Buff equals var buff. I'm gonna make a kilobyte sized buffer because my each line of my message is not greater than like a kilobyte. So after that, oh shit, no, you actually can. Okay, var I okay, byte int. I think this should work. So we're reading the data. We're gonna go for, man, I need to look at go by example loops. For I, okay, so you, okay, I forgot. For, so we have this guy, and I'm gonna name this bi. I 0, I smaller than count, I plus plus, and let me think. Data I. I don't think there's any issue here. If um, if data I equals backslash n, break, just break the loop, and I need a flag. Var flag equals to false. I hope this works. Yeah. So if you flag equal true, if flag is equals to true, then I'm gonna print out p, and then after that I'm gonna put bi equals 0, and I think that's it. I think that's it. And another thing that I'm going to do, var I equals to 0, and um, so if flag is equals to true, then it means we didn't read the buffer fully. No, 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 no. There's a chance that we didn't read the buffer fully. So for j 0, no, not 0. So data bi equals to uh, I think this should work. If the flag isn't true, we don't need a flag actually. We don't need a flag. If I if I is smaller than count, yeah, yeah. And if data is equal to backslash n, you break out of the loop. You have already read I. You have already read I. You don't need to do this I plus plus. And I think that's fine. I think that's I'm done. Uh, let us run it. So you have syntax error at 16 and 24. Uh, we have uh, why do you have this 16 colon 13 unexpected colon equal to, why is that? Okay, so if you don't write var, only then do you have to write. Okay. Uh, so you are still okay. So if you want to infer the type, uh, uh, there's an issue. There's an issue. It's a weird issue. We messed up. We have a buffer. What is going on? You read into data. If count is 0 and you're at the end of file, this is just normal. I equal to 0 for I till count I plus plus. You read. If none of this happens, I is equal to count. If none of this happens and I is equal to count, it should. Okay, I got it. This guy should not be here. Okay. So in any case, even if we reach the end of the loop, if we reach the end of the loop and we don't get any backslash n, we're gonna just put all of the data into the buffer. Um, I am doing something really wrong here. I'm doing something really wrong. Hmm. If I is equal to count, I equals to count. If I is equals to count, you just write to the buffer. Let's continue. And we don't need this. And in the latter case, I'm doing something stupid again. Why am I doing this, bro? Being really dumb here. To put stuff into the buffer, you only print. You will only print from the buffer. Okay. So you will only print from the buffer. You will only print from the buffer. And when will you not print? This is when will you not print. When you won't print, the printing needs to be in a special if, because you will have to write to the buffer anyways. Yeah. So in any case, when you encounter a backslash n, you break. Now, what do? We have written to the buffer if they, I is less than count, we print we print, and if it isn't, we don't print, and if it is, this guy is gonna fail. For I smaller than count, I plus plus, and if it didn't, we're gonna put buff bi. Nope, that's a stupid idea. Bi will be 0. I'm being dumb right now, I'm being super slow, but that is because I haven't programmed in a long time. Like I only started getting it programming again after like I think a few weeks when I started this stream. So if I remember correctly, so for I is just in count I plus plus, buff of bi will be data of I, and bi will be incremented, and that's it. This is a simple law. Now there is still something wrong here. Why do I always keep opening this guy? So we read data, then if we have reached the end of the file, we just break out of the loop, and we shouldn't just break out of the loop, we should print this. 13k p. We should print buffer till bi, and then we should break. And then if error is not equal to nil, we just we just log the error and we exit with our error status code. Then I is started with 0. Then I will go till count, and buffer will be assigned with the data, and then bi will be incremented. And then if data is equal to backslash n, I will be incremented because backslash n has been read, and then we will break out of the loop. If the number of bytes that has not been read is greater than 0, like there's still bytes left to read, then that means that we got this break statement, and then we will just print out the buffer. We will put bi equal to 0 because the previous data has already been printed. Then we will put whatever was left from the data array into buff, and then we'll break. We'll do bi plus plus, and then we'll break. I think now everything is fine. Yes, everything is fine. It took a long time, but since we struggle now, we're not gonna struggle later when we encounter something as simple as this. So we're getting back into the flow. It'll take time for me to go faster. I want to run it again. Okay, so it literally printed backslash as backslash. It's not that good, but We'll work with it for now because I don't want this backslash n to be literal created literally. Okay. Here's what I did: create a string variable to hold the contents of the current line of the file. It needs to persist between reads. Of course, after reading 8 bytes, switch the data on new lines to create a slice of strings parts, one or two parts before. What the hell happened here? Okay, so I, yeah, for each part except the last one, print a line to the console in this format. For each part except the last one. Why? I don't get this. What is this part thing? You create a slice of strings. Okay, okay. Okay, it says implementation. We don't need to care about it. For each part, there is the last one. Print a line to console in this format. Line is the current line we have aggregated so far. Current part and reset the current line variable to an empty string. That's what we're doing. We're not using a string. We're using a buffer. Note that if we only have one part, we don't need to print. We have not reached a new line yet. At the last part of the current line variable, it will reach the end of the file. Once you're done reading the file, if there's anything left in the current line variable, printed in the same read line format. Yeah, we're done here. We should just move on. Maybe we can replace our buffer with a string variable, whatever this is. Go as a string primitive apparently. String. The reason we're going so slow is because Go is super new to me and I have not been programming so much. So I am super slow. But hopefully with time I'll get faster because there isn't any strings and rules. Okay, I found it. A Go string is a read only slice of bytes, so you can only read strings. Okay. The language and the standard library treats strings specifically as containers of text encoded in UTF-8. In other languages, strings are made of characters. In Go, the concept of character is called a rune. It's an integer that represents a Unicode code point. This Go blog post is a good introduction to the topic. I really don't know much about UTF-8 except that it's every character of UTF-8 is varies from 1 to 4 bytes, and you can't like access a specific, and therefore you can't access like a specific index of UTF-8 string using like array indexing. Let me demonstrate. So of course, some languages may have wrappers over it, and it may seem like you're accessing an element of the string in one time, but in reality, what it's doing is it's starting from the start, and it reads until it gets a valid Unicode character, like say 3 bytes, and that so the first Unicode character is 3 bytes, and then it again reads until it realizes it has a valid UTF-8 character in the buffer. It is similar to how we were doing that printing stuff. Like we were putting stuff into the buffer until we got a back session. Here we what the way to get a specific the way to traverse this UTF-8 string is or to read or to interpret this UTF-8 string is to keep going until whatever we have read till now is a valid UTF-8 character. Then you print it, and then you empty your buffer of your bytes buffer. It's probably like a 4 bytes buffer, and then you start reading into that 4 bytes buffer again until you get a UTF-8 character, say like 4 bytes, and then you empty the buffer and you increment the index. So now you're at like index 2. And and let's say what Python will do is, if you have UTF-8 string in Python and you say like s index like 4, it won't just go to the pointer of the string and just add it won't just take an address of the starting of the string and let's just say it's 100x10. It's long address obviously. Let's just say for now that the starting point of the string is 0x10, and then it just adds like 4 bytes to that address to go to figure out the location of the S4, and then it just reads it. It doesn't work like that. What actually happens is, it starts at the starting point, it keeps reading things into a buffer until it makes sense, it then empties the buffer, increments the index, and then it reads again. So it really, when you're indexing UTF-8 strings, you're taking like O of n time, where n is the number of bytes of the string. I really drew badly, but I hope you got the point. So maybe that's why strings are read only here. Like you can't modify stuff like that. Can we modify strings in C? I think we can. Yes, we can actually. It's obvious. But I'll still show you. Like this is a C string. You can just like buff 7 equals to A, and like buff 8 equals to Y, and no, let's just do buff 0 and buff 1. So it did compile, and I'll just show you the message as well. Buff 2 equals to the ending character, the null character, and we'll just print f uh, percentage s and backslash n and buff. We'll just print buff. Yeah, just you got AY. And the reason is that you can't do that in Go is because Go doesn't want to hide from you the fact that to modify a string you have to like go all the way and then modify that thing, and maybe that's why it's saying that like you can't modify a string. I don't know. In other languages, strings are made of characters. In Go, the concept of a character is called a rune. It's an integer that represents the Unicode code point. So for characters, what they are doing is they're okay. They're probably doing something like this. For their concept of a rune, they're splitting this thing into 4 bytes, pieces of 4 bytes, and maybe they're like, if the Unicode character is like 1 byte, so what they're doing is they're like, this is the 1 byte, and maybe they're putting some sort of special character here which says like ignore me, ignore me, ignore me. Maybe it's like 0, it's like zeros. They're prefixing it with zeros, and then you have the actual value, say 47 or something, I don't know. And since you know you have 4 bytes, you can like index things as well, and you can work with things in a better way. That's why it's an integer. I don't know. Let's just go here because I think Unicode is UTF-8. It's not ASCII. Unicode is different. So unique. If you have UTF-8, you have 4 bytes, 1 to 4 bytes. Unicode varies between 1 to 4 bytes. I actually read this in the Rust talks. There was like all sorts of hype around Rust, and I just went to the learn section and started reading the talks. And I didn't actually build anything. I was too much of a beginner to actually even think of what to build. But I did understand most of the stuff. I don't know where's the book. Learn, getting starting with read the book. Yeah. So it's somewhere here. Rust strings. Let me just, yeah. You can read about this stuff. Uh, you can like read the stuff. I don't want to waste time on it. It's somewhere here. We talked about strings. Yeah. Let me find. Let's just control F byte. Uh, yeah. Uh, in this case, length will be 4 because each of those letters takes 1 byte. But here, uh, yeah, Rust sans is 24 because that's the amount of bytes it takes to encode this guy in UTF-8, and uh, because each Unicode scalar value in the string takes 2 bytes of storage. That's what I was talking about. Like you have a variable number of bytes for encoding any character in UTF-8. It can be 1, it can be 2, it can be 3, it can be 4. And the way you read UTF-8 strings, actual UTF-8 strings, not something like a rune where you have like this prefixing of zeros, is you keep reading into a buffer until what is in that buffer is a valid Unicode character, and then you print it, and then you empty the 4 byte buffer, and then you keep reading into it again, and after each append of a character of a byte, you check whether or not it makes sense. Let's just erase all of this, and then we'll continue. Yeah, we can read this, but we're taking too much time. Or should we read this? Maybe we should. But not building anything like it ends here, I guess. Uh, yeah, I think it's the end of the course. Like it's not that big of a course. Oh, sorry. You have a lot of chapters. Maybe we should speed up. Maybe we should just continue at this pace. Maybe our slow pace will serve us later on when we do this stuff or handle bigger Go projects. These concepts may help us. So I'm gonna read it. And if with beginning this reading, I also, if I read this, I'm also gonna have to make something significant because otherwise this will just be a waste of time. Because if all I wanted to do in Go was to follow a tutorial, my code is already working. I don't need to go into all this stuff. So okay, let's just read it. The previous blog post explained how slices work in Go using a number of examples to illustrate the mechanism behind their implementation. Building on that background, this post discusses strings in Go. At first, string might seem too simple of a topic for blog post, but to use them well requires understanding of not how they work, but also the difference between a byte, a character, and a rune. The difference between Unicode and UTF-8, the difference between a string. Okay, so Unicode and UTF-8 are different. I didn't know that. The difference between a string and a string, literal and even more subtle distinctions. One way to approach this topic is to think of it as an answer to the frequently asked question, when I index a ghosting at position n, why don't I get the nth character? As you'll see, this question leads us to many details about how text works in the modern world. An excellent introduction to some of these issues independent of Go is Joe Spolsky's famous blog post, blah 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 blah. Maybe I'll read it off stream. Many of the points he raises will be echoed here. What is a string? Let's start with some basics. In Go, a string is in effect a read-only slice of bytes. Okay, you have a slice of bytes. Okay, if you are at all uncertain about what a slice of bytes is or how it works, please read. I won't read. I pretty much know what a slice of bytes is. It's important to state right up front that a string holds arbitrary bytes. It's not required to hold Unicode text, UTF-8 text, or any other predefined format. As far as the content of a string is concerned, it is exactly equivalent to a slice of bytes. Okay, here is a string, little more about those soon, that uses the $xnn notation to define a string constant holding some peculiar byte values. Of course, bytes range from hex values, blah 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 blah. Yeah, obviously, bytes are two hex. One byte can be represented as two hexes, and I can show that. Should I? Let's just. So you have a byte. You have uh, 0, 0, 0, 0, 0, 0, 0, 0, and what is the maximum value that can be represented by those bytes is this: 4, 5, 6, 7, 8. This corresponds to the power of 0. So you can get the actual value corresponding to these bytes by multiplying this guy with 2 to the power of 0, this guy 2 to the power of 1, and so on. And the sum of all of this would be 2 to the power of I for all I from 0 till 7, because 0, 1, 2, 3, 4, 5, 6, 7, 0 is maximum. And that would be, let me recall what the geometric series formula is. I think I've wrote it somewhere here. I haven't. I thought I did right. I like derived the geometric series. Maybe I'll derive it as well. Like, I always forget it and I have to derive it again and again. S is equals to A R0 power 0 plus AR power 1 plus so on until AR power of n minus 1. Okay, and this is S underscore S sum of n. And if I oh shit, and if I have like R multiplied by Sn, then I have like A power AR1 plus AR2 plus ARN, and if I subtract these two, I have like S underscore n minus R into S underscore n, and it is equals to, if you notice, AR0 will be left, these guys will be subtracted from each other, and so on, and this guy will also be subtracted from the an equivalent guy here, and this guy will be left. So it will be a r to the power of 0 minus a r to the power of n, and if I take common n, 1 minus r equals to a, r power 0 is 1, so I can safely remove this guy, and I can take a as common in here as well, r power n, and Sn is equal to this guy divided by this guy. So I can just cut this and this. Yeah. So what is our a here? A is the initial value. A is 1. We can just ignore that. 1 minus r to the power of n. What is n here? N is 7. So 1 minus r. What is r? R is 2. So 1 minus 2 to the power of 7 over 1 minus Python 3. 1 minus 2 to the power of 7 over, I already know the answer to this. I'm just wasting time here. It's like 255. I already know the answer to this, but I'm just doing it for the heck of it. It's just easy. It's just something I have stored in my memory, but I'm doing this for a viewer who may not know. 1 minus 2 to the power 7 over 1 minus r. R was 2. Minus 1. So we don't need to do the minus 1 thing. So minus 1 is 7. You can multiply that by positive 1. I think I'm making a mistake here. Yeah. Okay. So 0, 1, 2, 3, 4, 5, 7. N is 8 actually. N is 8. 8. And we can put a minus here. So you have 255. That is a long-winded way of saying something I already know. Now what we need to do is the largest value that can be represented in a 2-digit hexadecimal is this 0xFF. This is 16 to the power of 0 multiplied by 15, and this is like 16 to the power of 1 multiplied by 15. 16 to the power of 0 is 1, 1 multiplied by 15 is 15, and this is 16 into 15, whatever it is. Let's just 16 into 15 into 16 plus 15, and you have 255. So every 8-bit integer from the smallest to the largest can be, every 8-bit number binary number can be represented as a 2-digit hex. Let's just move on. I shouldn't have taken this detour. It's probably people already know this. I don't know. Okay. Blah 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 blah. So where were we? Yeah, we were talking about these hex values. So backslash s probably represents hex here, and here is string literal that uses the backslash x and a notation. Oh, okay. And printing strings, because some of these bytes in the ASCII sample string are not valid ASCII, not even valid UTF-8. Printing the string directly will produce ugly output. The simple print statement produces this mess whose exact appearance messes with the environment. Okay, they are not valid ASCII. How? What's not valid ASCII here? . Like ASCII, as far as I know, everything in ASCII is like this is the ASCII table, and like what is not, maybe some characters are not printable. That's what they're talking about. Like how will you print like device control one or something? Let's actually see what problem this guy has with it. Let's just move this away. BD. How do you convert hex to non-hex? Let's just manually convert it. 16 into what's B? 11 plus 13. So it's 189. 189. 189. So it's like fraction one half. It's weird. I don't know what's gonna happen here. Like it's printed like this. It's weird. Let's just say it's weird and move on. I don't want to. Is there anything interesting here? Wow, yeah, it produces a mess. To find out what string really knows, we need to take it apart and examine the pieces. There are several ways to do this, blah blah blah. Most obvious is to do over its contents. Okay, and uh, okay, okay, okay. So you have a %x. It dumps out the sequential bytes of the string as hex digits, 2 per byte. Yeah, 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 yeah. A nice trick is to use the space flag in that format, putting a space between the percentage and the x. Yeah, you have something like that in printf as well. I don't remember exactly. We have something like that. There's more. The quoted verb will escape any non-printable byte sequences in a string, so the output is unambiguous. We have used this quoted verb, and it also adds quotes. We also know that. Okay. Um, we can keep on reading, but I don't want to. We'll read this later. I just want to progress a little bit in the program. Yeah, I'll just move this guy to another window. Uh, let's just move this guy to a new desktop. Maybe I'll read it in the next stream or something. I don't know. For now, let's just leave it. Reading 8 bytes at a time is a good start, but 8-byte chunks aren't how people tend to communicate. You probably noticed that it was hard to reach the individual messages through your program. Uh, nope, not that much. Let's update the code to read 8 bytes at a time, but let's format the output line by line. Have we already done this? I think we have done this. We already done this. Channel refactoring. If you wrote your code like mine, there's a good chance that you've got a little state machine going on directly inside the main function. Let's refactor our code so we can have a nice reusable function that reads lines from a TCP connection. So you want to create a function with this signature, the fio.read closer, whatever that is, chan string Okay, so this is weird. We need to know what channels are now. It creates a channel of strings. It does the reading loop inside a Go routine. Now we have Go routines. It does not prefix the lines with read or add a new character at the end. Oh, wow, we're gonna have to do a lot of reading for this. I'm gonna do it in the next stream. I don't want to read right now. I just want to go to sleep. We're going slow, but I promise we'll get fast. I don't promise. I hope we'll get faster as we go to like chapter 3 or 4, because by then we'll have a good idea of Golang. Search query equals HTTP. Let's put that. I should get my stream here. Like maybe I'll get like live. Okay. So how much time has already passed? Okay, so the over an hour has passed. I think I'll end here. We'll stream more maybe tomorrow, maybe after I eat something. But I just want to stop now. Maybe we'll just read articles. I'll just read articles today or tomorrow. I don't know. Like those articles about Go and stuff. Like you need to know the language if you're gonna work in it.